It's going.
Hi, I'm Kelly,
Hi, and I'm David.
and this is our final project presentation for Electrical Engineering 3. So the goal of our project was to create a motor that has multiple functionalities and that it turns either way. To do this, we had to create a circuit, including the motor within it, but we had to be able to interact with the circuit such that current could flow in either direction across the motor, depending on how we interacted with the circuit. So this implies that we have to manipulate voltages at either side of the motor on either node within the circuit. So for instance, in the first case, we would want the voltage at node V sub A to be greater than the voltage at node V sub B such that current would flow across the motor toward the right. And alternately, we would want to create a circuit such that we would be able to interact with it to induce voltage to be greater at V sub B than the voltage at V sub A. And our project was basically figuring out how we could find a way to do that. So to build the circuit, we used multiple components, including photoresistors, which are pictured here. We used transistors, which are pictured here. And we additionally used some resistors, including these two and this large one, as well as the actual motor component itself. So photoresistors are light-dependent resistors that can have a varying resistance based on exposure to light. When exposure to light is high, the photoresistors will exhibit low resistance in the circuit. Meanwhile, if you block the receptors from light, resistance will spike instantaneously. Transistors, on the other hand, we're using them in our circuit as switches, um, essentially by manipulating current and voltage that comes to the base legs of each transistor. We can affect whether current will flow through the transistor from collector to emitter or emitter to collector, depending on which transistor we're talking about. So some challenges we came upon when trying to build these circuits include resistor placement. So as shown here in the first diagram, initially we did not include this resistor here. We only had the photoresistor. We were trying to find the voltage drop across it to see why our circuit wasn't working. And we realized that by only having a photoresistor within a circuit, if you shorted this resistor here, it was irrelevant what resistance we induced upon the photoresistor by manipulating exposure to light because all voltage had to drop across that one circuit component. So we realized that we had to include a stable same level or same value resistance resistor in the circuit such that there were two components across which voltage could drop. And this was important because by varying this resistance, we could then manipulate current flow because not all voltage had to drop across this one component and change across these two nodes here. Meanwhile, we also had to deal with where to place the motor. How would we create a circuit that would allow current flow in either direction? And we discovered that to do this, we would need to actually connect the motor to two different sources of voltage. And we could then connect the motor to ground such that we could create a variance through this way such that current would flow from high potential to low potential. Alternately, we create a situation where the ground could also act as the high potential point and the current could flow the opposite way to the lower potential.
Okay, so this is our final schematic for our overall circuit, and the magic behind our circuit lies mainly within our two transistors, as seen here. So our top transistor is a NPN transistor, and our bottom transistor is a PNP transistor. And the main difference between these two is that in a NPN transistor, current flows from the emitter, from the collector to the emitter, and in a PNP transistor, current flows from the emitter to the collector. And another difference for these two transistors is that in an NPN transistor, it is turned on when current is flowing into the base, and for a PNP transistor, it is turned on when current is flowing out of the base. So what that means is in order for our top NPN transistor to be turned on, we must have a positive voltage at the base in comparison in relatively to a negative voltage at the emitter. And for our PNP transistor, we must have a negative voltage at the base relative to the emitter. So as my partner was saying, the photoresistors we were using increases in resistance as we cover it. So in this scenario, if we leave both photoresistors open, uncovered, the voltage between them will be around 0, and the voltage between the two emitters of the transistor is also 0 because it is tied to ground. So what that means is in this scenario, neither transistors will be turned on, so the motor would not turn. But if we were to cover one of these photoresistors, then, for example, if I were to cover R2, the resistance here would increase greatly, meaning our voltage between these two would be closer to the negative 5 volts, which would then in turn turn on Q2, so which will allow current to flow through it, driving the motor. And the opposite would happen if I were to cover R3 right here. That would turn on this transistor and current would flow through here, turning the motor the other way. So yeah, that's pretty much how our circuit works. And this is just a picture of our overall design. So what we ended up doing with our design is that we disconnected the two photoresistors from our main breadboard and we attached it to a separate breadboard so we could, manipulate it in a cool way to assemble our project. And what we ended up doing was after moving the two photoresistors onto a new breadboard, we built this sort of like a trap dome circuit that you could see in our presentation video. But essentially, here's the motor driving the trap dome, and this dome is activated by the two photoresistors seen here at the bottom. And this could all be seen in our presentation video. But yeah, cool. Thank you.